Now let's look at 2019, question 5, part A. This was a reasonably long part A. Starts nice and steady, and the last bit is a little bit tricky. So we have a whole lot of different bits and pieces going on here. We're going to start, as always, by drawing a diagram. Two spheres. Sphere A, mass 3m. Sphere B, mass m. Okay, A is going this way, speed u, and B is going this way. Okay, at speed u, so we're going to call velocity minus u. There's a wall they're going to hit over here. Coefficient of restitution between the spheres is 1/2, and between the wall is 2/5. Okay, so that's all our bits and pieces laid out, and we can kind of see where we're going now a little bit more clearly. What we see is in part 1, we want the speed of each sphere after the collision. Well, that's completely bog standard collision work for us, so no big deal. We're going to lay out our terminology, UA and UB, and VA and VB. Just to be clear, UA is U, UB is minus U, and we'll call these guys V1 and V2 because we may have other collisions with these later on, and this will make life a little bit easier. With all of these ones, we use Newton's law of restitution, followed by the principle of conservation of momentum. Newton's law of restitution first. Well, that is going to be V1 minus V2 over U1 minus U2 equals minus E. That's just the general form of it. So in our case, that's going to be V1 minus V2 all over U minus U equals minus 1/2. All right, let's tidy that up a little bit. V1 minus V2 equals, that's 2U, so minus 2U over 2, and they cancel, so V1 minus V2 is minus U. There's our first little equation. Principle of conservation of momentum. So we have, in this course, the general form is M1U1, M2U2, M1V1 plus M2V2, and by the time you finish this, your course, you'll be so sick of writing that out, but you will know it. This is not one to be wasting your time looking up. You want to know it. Okay, putting our values in. 3mu minus mu plus m by minus u equals 3mv1 plus mv2. Cancel your m's, we can say goodbye to them now, and we end up with 2u equals 3v1 plus v2. And that's equation 2. Now, sometimes we have to get a little bit complicated, but this one is nice and tidy because we have a minus v2 there and a plus v2 there. So we'll just bring 1 over here to it, and we end up with minus u equals v1 minus v2. Bring them together, they're going to cancel out, and I end up with u equals 4v1. So v1 is u over 4. Brilliant, getting there nicely. We're going to come over here because this looks like a lovely little equation. So in this case, we know that v2, bringing it over here, equals v1 plus u. So sub in u over 4 plus u, so of course v2 will fit in there nicely. v2 equals 5 over 4 u. There we are, just nicely on camera. That's part 1 all sorted. Okay, now part 2. B is going to hit a wall, it's going to come back, there's going to loads of stuff happening at different distances, and we need to find the value of u. So this is getting kind of messy. So what we're going to do is we're going to break this down into a few little bits. First of all, let's deal with the collision from B into the wall. All right. Now, in this case, the wall doesn't change, so we're just going to be using the equation v over u equals minus e. It's kind of our more basic form of the whole equation. So in this case, v is going to be v3. U, well, it's b moving, so hang on a second, b is v2, so it's 5 over 4u, okay. 5 over 4u equals minus 2 over 5. Okay, now we're in a slightly better situation. We'll lose the 4 because that's just going to annoy me anyway, at the very least. So v3 over 5u equals minus 2, and I multiply the bottoms by 4 over 20. So v3 equals minus 10u over 20, which means v3 is of course minus u over 2. Now we're set up a little bit better to begin to think about what's happening at the wall. Okay, for the wall, because a little bit of thinking in this one, we're going to go to a new sheet for it. Now, let's have a little look at this and see what we know. We know the first collision occurred 2 meters from the wall. So diagram, there's the wall, there's A, there's B, 2 meters. Okay, we are going to consider these spheres small enough that the radius of them is irrelevant. Okay, so teeny tiny marbles, something like that. 2 meters from the wall. Then they collided again a little while after it. So this is getting kind of messy. So basically what happened is B moved over this way, hit the wall, came back a little bit. Meanwhile, A moved forward and they had another collision around here. So let's look at this in terms of time. It's going to call that one time 1 and time 2. Because the reason I think of this is I can figure out, I got a distance, I know the speed of B, I can figure out this time fairly easily. And then we'll deal with the slightly trickier bit over here. So in this case, using S equals ut, 2 meters, looking this for B, is, well, speed of B is, and we're going to go back and double check to be really sure, we're not going to make a mess of this one, is v2, so there it is there. 5u over 4 t1. Now I can rearrange that, and t1 of course becomes 8 over 5u. Alright, so I know I'm getting a little bit closer. There's a little aside here, t1 plus t2 equals 4. Scribble that down somewhere so we don't forget it. Well, what are we going to do next? It's getting a little bit messy here, so what we're going to do is look at it in another situation. There we are. Let's look at the point when B hits the wall. There's B on the wall. Now in this case, A is now a little bit closer. Remember, A was there. Okay, so that distance there to there is 2 meters. And what about these different distances here? Well, let's look at this distance here for the moment, because this happened S in time 1. This is how far it moved in the time it took B to get to the wall. And we've defined T1 as B hitting the wall. Well, that's not so bad because we know the speed of A and we do have an expression for T1. So let's see what we can figure out in all of this one. So again, S equals ut. So in our case, we're looking for the distance. A, if we go back to our original one, V1 is VA, so we label everything nice and clearly. There it is, U over 4. It's U over 4 by T1. Well, let's sub in T1. S equals U over 4 by 8 over 5U. Oh, look at this, isn't this nice? The U's are going to go away on us. So this distance here, equals 8 over 20, or 0.4 meters. So we can call that 0.4, which makes this distance here 1.6 meters. Now we know a little bit more. So let's think about what's happening at this point, okay? Because we now know the speed of this guy. So it's coming back off the wall at speed u over 2. Double check that. There it is, u over 2, minus u over 2 because it's going this way, so u over 2. This guy has always been moving at u over 4 since the first collision. So this is going to come together a whole lot nicer. Our only unknown is the time it takes. So let's lay this one out. And we'll just come up here. So in this case, again using s equals ut, 1.6. Now, that distance is going to be covered by these two combined. So it's going to be u over 4 by t2 plus u over 2 by t2, because both of them are moving together to close the gap. Well, 1.6 equals 3/4 u by t2. So we're getting there. We just still need to, and we want to solve for u. We have two unknowns. I need to get rid of this guy. And at this point, that's why we scribble that down on the side of the page, because that is the key to the whole thing. In this case, t2 is 4 minus t1, and that equals t2, 4 minus 8 over 5u. So that is what we're going to sub into here. 1.6 equals 3 over 4 for the u up the top here, because I'm hoping it'll cancel out, and I suspect it might. A factor of 4 minus 8 over 5u. Now, a little bit of ugliness before we solve this out. 1.6 equals 3u, that's nice and handy, minus, and if in doubt you can kind of lay it all out, but actually we'll figure this out, minus 24u over 20u, cancel. So we're going to bring this over the other side, so 3u equals 1.6 plus 24 over 20. Again, I'm not going to be doing too many multiple substitutions. And this one, so I cleverly left my calculator in the other room for this one, but we'll just do this nice and quickly in our head. So that is 1.6 plus 14 over 12 over 10, 12 over 10. 1.2, so 3u equals 1.8, 2.8. Time for a cup of coffee, which means u equals 2.8 over 3, and that equals something I will need to do with a calculator, but if we do a little bit of a double check here and a sneaky one, we will of course realize that equals 0.93. Alright, and there we have it. So this required quite a bit of thinking in terms of laying out, finding different ways we can look at it to slowly chip away at our variables. A real key part of getting this figured out was making sure we wrote that down and knew it, and then we can just lay it out and move through it. We're looking at time, well let's figure out t1, and we're slowly moving towards a solution we know.